Okay, so this is another combo packet. We're gonna do area of trapezoid and regular polygons, okay? And find the area of 30, 60, 90 triangle with hypotenuse 5. So you got hypotenuse 5. You can get the length. This is 90 degree. You can get the area. Find the area of rectangle with length 6 inscribed in a circle with radius 5. So rectangle is inscribed in the circle. So there's a circle and rectangle is inside. Did we do this in the pocket? Maybe it's a different number, right? And so let's call this a 6. And here is the center. Here is the radius. 90 degree. This is 3. Radius is 5. You can get this length and you can get the area. We did this problem yesterday in the pocket with a different number. So get these numbers, okay? Typical kind of problem you get on the quiz and tests. All right, so we did this and we did rectangles, parallelogram, triangle numbers yesterday. Trapezoid and regular polygons in this pocket, okay? So let's just write that there. Know and use the formulas. Formulae and formulas are both plurals, in case you're wondering. For the areas of trapezoid and regular polygons. Okay? All right, here is trapezoid, area of trapezoid. The area of a trapezoid equals half the product of the height and the sum of the bases. And here is key steps for proofs. I think it's easier. Well, let's go through this. Draw a diagonal BD of a trap and trap ABCD, forming a two triangular regions, 1 and 2. 1 and each have a height of h. The area of a trapezoid is area 1 plus area of 2. And area 1 is 1/2 of base 1 times height. And area 2 is 1/2 of this base times height. So if you clean this up, you get this. Oh no, it's already cleaned up. Okay, so that's one proof. The other proof is this. Here's one trap. This kind of look like isosceles trapezoid, but it doesn't matter. I'm gonna draw another one, but it doesn't look like isosceles trapezoid. Here's another one. Okay, if you flip this and then put it over here, so this I just flipped it and then put it over here like this. So actually, think of it as this side is shared, right? It's the same side. And then this side went over there, this side went over there, and this side went over there. Okay? If we do this, this side is sum of two bases, right? Sum of two bases. It should have the same length. It's going to be a parallelogram, no matter what the trap is. And the height is same everywhere, right? So if you do the base, which is the sum of the two bases of trapezoid, which is this, times height, you get this parallelogram. And you have two of these, so making it 1/2, you get the area of trapezoid. Okay, so that's what this is. All right, so here's a trap practice. Okay, find the area of isosceles trapezoid with leg of 5 and base of 6 and 10. Okay, so in this problem they gave you 2 here, but in the regular problem you're not going to get this. You have to know that if this is 6 and that's 10 and it's isosceles, you should get 2 and 2. You got 2 and 5, you can get height, get the area. Okay, and all right, do these two homework. Okay, get the area of this and the area of this. All right. Don't get thrown off by this looking thing. This is still trapezoid, one pair of parallel lines. Okay, these are trapezoid. So you just do 2 base times height. Okay, you have to get the height though. All right, here's more interesting stuff, I think, the regular polygons. All these problems, you usually get a square or equilateral triangles or hexagon. If it's, so here's another. The typical problem is these 3 for area polygons. Okay, because, like I say, these 2, like I always say, these 2 are 30, 60, 90 triangles, and this is 1, 1, 2 triangle, the 45, 45, 90 triangle, right? Any other polygon that is different shape, so it's not 3, 4, or 6, you have to use a trig, because the angle that you're going to get is not going to be one of the angles that we like. Okay, so just a heads up, we have to use trig for non-special triangle problems. Okay, center of a regular polygon is the center of the circumscribed circle. The radius of a regular polygon is the distance from the center to a vertex. Central angle of a regular polygon is an angle formed by 2 radii. These are radii. Okay, drawn 2 consecutive vertices. The apothem, that's a new word here, apothem of a regular polygon is a perpendicular distance from the center of the polygon to a side. So here's a picture right here. This is apothem. Think of it as any polygon you can make isosceles triangle by the number of sides. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a decagon, right? So you get the 10 congruent isosceles triangles. If it's octagon, you're going to get 8 congruent isosceles triangles. They're isosceles because radii of regular polygons are all congruent, right? So to get the area of a polygon, you have to get the area of a triangle and then multiply by number of sides. Okay, and to get the area of a triangle, you need to know the height of the triangle, right? And this height is called apothem. Okay, apothem of a regular polygon is a perpendicular distance from the center of the polygon to the side. Okay, which is different from the radii of a polygon, which is longer. This is hypotenuse. This is one of the legs. Could be long leg or could be short leg, depending on the shape. Okay, center of regular octagon is O. The radii is these. Central angle is these. And measure of central angle, you just do divided 360 divided by number of sides. In case of octagon, it's 45. And apothem is OX. And this is the theorem. Just so you know how to get the area of octagon if they give you, for example, the side is 10. Okay, this is isosceles, so this is bisect, so this is 5, right? And you can get this angle, right? This is 45 divided by 2, and you know the opposite side. You want to know the adjacent. So it's opposite and adjacent. You're going to use a tangent. So tangent of 45 over 2 have to equal opposite over OX, adjacent. And you solve for OX, you get the height, you get the base is 10 times height times 1/2, you get this area times 8. That's how you get the area of octagon. Okay, already here is okay, so if you know the apothem and the perimeter of a regular polygon, you can use the next theorem to find the area of polygon. So it's basically what I just did. The area of a triangle, regular polygon, is equal to half the product of the apothem and the perimeter. Okay, and then I just go over this, it will make sense. Okay, so apothem times the base times 1/2 is going to give you this, right? And then you're going to get the multiple of the same area based on how many polygons you have. Okay, so this is what it is. Area of each triangle is 1/2 of the side times apothem. Okay, area of the polygon is how many sides do you have times the area of each triangle, right? N times 1/2 of the length of the side times apothem. So far so good. So when you're multiplying, you can change the orders and it's still the same thing. So 1/2 over apothem times number of the side times how long each side is. Okay, and since how many side is there and how long is the side will give you perimeter. Area of a polygon is perimeter so the perimeter is P, which is NS, number of side times how long the side is, times apothem times 1/2. Okay, I don't care how you do this on the test, whether you want to get individual triangle area and multiply by number of triangle you have, or you do apothem times the perimeter times 1/2. You get the same results, just use whichever you feel comfortable. Okay, all right, so let's just do this one together. Find the area of a regular hexagon. Okay, so and then I'm going to show you the two ways that I just explained to you. I personally think getting the area of a triangle and then multiplying by side is more intuitive. Did I do it right? Well, this is supposed to be straight line. Anyway, 1, 2, 3, 4, 5, 6, 7. Oh, I draw an octagon. That's why. That's why it's not straight line. Hold on one more time. Let's do it again. Okay. 1, 2, 3, 4, 5, 6. That's why. All right, here we go. All right, here's the hexagon. Okay, and the apothem is 9. This is 9. Okay, that's the apothem. So this was 60 degrees and this is 60 degrees. So now this is 30, right? So this is the long leg. This is the short leg. So this is 9 over root 3. This length right here. Okay, and I know that many of you want to make this a non-fraction, so that's fine, just to do rationalize it. You don't have to though. You only need to rationalize the answer. So you get the 3 over 9 root 3, which is 3 root 3. Okay? So area of this triangle is the base times height times 1/2. But since we have the half of the base already, you don't have to get the whole base times half and 1/2. You just can do half of the base times height to get this area. So 9 times 3 root 3 is what? 27 root 3 would be the area of this triangle, right? If you don't know what I just did, the base is 2 times this, so it's 6 root 3, right? The base is 6 root 3 times 9 times 1/2 will give you, this will make it 3, and 27, it's the same answer, 27 root 3. Okay? So when all these problems, you have to get the half the base anyway. So don't increase the work by doing times 2, multiply by this, and then divide by half. Just do the half the base times height to get the area. Now, so one hexagon is 27 root 3. So 27 root 3 times 6 would give you, hold on, 27 times 6 is 162 root 3 and unit squared. Okay, now let's do the theorem way. Okay, apothem is 9, so this is 9 root 3 or 3 root 3. So one base is 6 root 3, right? And then there are 6 of them, right? 6 sides, so times 6, you get 36 root 3. And the area is 1/2 of the apothem times the perimeter. So you divide by half and you get 18, and 18 times 9 is 162 root 3 units squared. Okay, either way you get the same answer. I don't really care which method you prefer to use. Okay, if the problem already give you a perimeter, go this way. You just get a apothem, and then if you get the information about the side of the triangle, go this way maybe. Or you can just stick to one method. Either way is fine. Okay? Alright, and this is the trig one. So just if you get confused, just watch this one again, the one that I just did. Okay, this was octagon, and this is 9 sides, so nonagon. Okay, but the concept is the same, so do this one for homework. Okay, and find the perimeter of the area of each regular polygon described. Exercise starts here. Okay, so I want to try all this. Okay, you have to use A's on an S. So this is a good practice for those of you who don't like the alphabet. Okay, and these are like bread and butter of this section. See the square and equilateral triangle and hexagon. You have to get for each regular polygon shown, find the perimeter, the measure of a central angle, apothem, and the radius R and area A when the side is 4, and side is 4. Okay, so I want you to do all three. This is like a bread and butter of this section, and you have to be able to do this. So homework, and this is gonna be most likely be the survey question, one of these. Okay, and the rest we do in the class. All right, don't forget to bring pie for Pi Day.